My name is Adam Thomas from the NIMH Data Science and Sharing team in the intramural program, and we are very pleased to open Jason Priem. So welcome, Jason Priem, from OurResearch today. Jason has done a number of great work that has really increased accessibility and transparency in the bibliometric and meta-science literature. You can read all about that at their research, at their website, ourresearch.org. But today he's going to talk to us about OpenAlex. Jason.
Thank you so much for that introduction. I appreciate that. And I'm extremely excited to be speaking at the NIH. I'm a huge NIH fanboy, so this is a super big honor. I really appreciate the invitation. Today I'm going to be talking about OpenAlex, which is an open and complete index of the global research system. So specifically, I'm going to be trying to make 3 points today. Number one, that scientific knowledge graphs, and we'll talk about what that is in a second, but scientific knowledge graphs like Scopus or Web of Science are vital, but that they're closed and therefore broken. Then I'm also going to try to say that OpenAlex is an open scientific knowledge graph with excellent coverage. And, whoa, I just lost my display for a second. That's all right. Sorry, we're having a little technical issues. We'll get them cleaned up in a second for y'all. Are we good? Yep. Awesome, thank you. Yeah, so my second point is that OpenAlex is an open scientific knowledge graph with excellent coverage. And the third one is that you should use OpenAlex. That's what I would like you to do. And we'll see if I do a good job of convincing folks of that or not. So my first point is that scientific knowledge graphs are essential infrastructure. So what does that mean? What's a scientific knowledge graph? It's easier probably to explain it by example. So a lot of y'all have probably used things like Web of Science or Scopus or Google Scholar. Few people may have used Microsoft Academic Graph or Dimensions. And then a smaller number of people may have heard of things like Crossref, COSI, which is sort of an index of Crossref citations, and OpenAIR. And there's actually a number of other scientific graphs that we could probably name as well. I'm just kind of picking sort of a sample of some of the biggest ones. Web of Science and Scopus are by far the most popular. If we wanted to talk about a scientific knowledge graph, and I should say, the scientific knowledge graph is a bit of a new term, and so some people kind of put different ones of these systems in that term, and some people don't. I'm kind of using a broad definition of it. But what that means is all the products of science, right, so the papers and the data sets and things like that, all the people who do science, right, the authors, scientists, researchers, all of the venues or the journals that host that science, the institutions where the scientists or the researchers work, and then maybe some other things like the concepts or funders sometimes are also included in that list as well. And these are things that are all connected, right? So works cite other works, authors or researchers author works. And so the reason why we call this a graph in the mathematical sense, right, is we've got all these little nodes of little items, of things, entities, and all these edges, which are connections between the entities. So knowledge graphs would kind of become a big thing, and so I think that's why what formerly might have been called a bibliographic index or database or metadata database now is increasingly getting lumped in this scientific knowledge graph category. So these are really important. We use these for a lot of discovery. So if you're a scientist or a researcher, a lot of times you will use something like Scopus or Web of Science to do research, to try and find out new papers you might read based on who's cited some of the work that you already care about, based on a full text search. And so sometimes it's kind of a discovery use case. It's also, however, when we're talking about the underlying graph, we're talking about the data behind these tools, we're interested not just in finding a specific article, but a lot of times we're interested in more of a broader picture. And that broader picture might be something like, I just went to a conference where people were presenting on some of these. So there might be a picture of, do more gender diverse teams in science produce more highly cited scholarly papers? Right? That's kind of a broader question, right? I don't want a specific paper, I just want to learn something about how science works. And there's two reasons why I might care about that type of, or let me give you another example, just so we don't have just one. An example might be, just off the top of my head, are countries in the global north more likely to have a large percentage of their scientific output be open access compared to countries in the global south? That might be another question that I might want. And there's literally infinite questions, right, that we could answer about this. So we could ask how things have changed over time, right? We could ask questions about people, about concepts, about things. there's two reasons why I want to ask these questions. One of them is just academic interest, right? I'm just kind of curious about how science works. I think science is cool. I want to learn more about it. In terms of impact, probably the much broader one, the much more significant question is not just, hey, I'm curious, but rather, how should we spend our money, right? Like, scientific research is a billions and billions of dollars a year sort of proposition, and ideally we would fund everything, right? Every kind of scientific question, we throw money at it, but we don't have infinite money, so we have to kind of decide where should we put that money. And so that's where this becomes an extremely societally significant question, where these scientific knowledge graphs, they become the telescope by which we observe whether our funding is being successful or not, and moreover, not just observe, but we also decide where to put that funding, right? It's the instrument, it's the microscope, it's the telescope, it's the ruler, wherever you want to call it, but that's the instrument that we use to determine where our funding is making impact, and therefore where we should put our funding. So it's an extremely significant component of the scientific enterprise, these scientific knowledge graphs. But even though they're very important, even though we use these scientific knowledge graphs to determine billions and billions of dollars worth of funding allocations, right? We use them to make all kinds of decisions about where our funding should go. They're paid for view. They're pay to view. In other words, if I wanted to look at Scopus, I wanted to look at Web of Science, if I wanted to examine their data, I would need to pay a significant amount of money to do that. And when I say significant money, I'm talking, depending on the size of the institution, definitely tens of thousands of dollars, sometimes even more, maybe hundreds of thousands of dollars. So it's extremely expensive. And that's a bad thing. The reason why it's a bad thing is because people can't afford that money. Even after they pay the money, they can't share the data that they get. And then finally, they can't build on those tools. So let's talk a little bit about can't afford them. What's that mean by that? I mean, when I say can't afford them, I think the big question is who can't afford them, right? Like, I mean, because some people are, right? I mean, Scopus is making hundreds of millions of dollars a year, I think, like crazy amounts of money. So some people can afford them. So the question isn't, can we afford it? It's who can't afford them? And of course, the answer is poor people, right? People who don't have a lot of money. And there's a lot of people who maybe don't have the money to buy into this system. But the one that I think perhaps the most concerning is less wealthy regions, right? Like, there's big swaths of the world where the idea of spending tens of thousands of dollars for one of these scientific knowledge graphs is just, it's not going to happen. The money's not there. And so what that means is we're systematically excluding those regions from using scientific knowledge graphs and from really understanding the research that they themselves create, right? So if I live in, if I'm in a region that doesn't have a lot of money and I want to try and figure out, hey, is my money being used well? Like, what research is highly cited? How much open access are we producing? Those are questions that are very difficult for me to answer right now because I can't afford access to the knowledge graphs that would let me answer those questions. And that's pretty bad because we don't really want to be systematically excluding huge regions of the world from scientific enterprise. That's something a lot of people are interested in trying to solve right now. And it seems like excluding them from the scientific knowledge graphs would be a particularly concerning area. And I think that makes me want to ask the question. I wonder if that's why tools like Scopus or WAS, right, these big commercial sort of premier systems, they've got extremely poor coverage of non-English articles, right? Because it's kind of like, well, no one who doesn't speak English is our customers, right? Like, it's the developed world, the rich world, basically, who's buying this. They mostly write in English, so we're only going to cover English, right? So you end up with this kind of like vicious cycle where the tools are not very useful for folks in the less developed world, and furthermore, they can't afford them even if they were useful, and therefore they never get useful. So this seems like a pretty bad thing to me, and it doesn't just apply to the less developed world. That would be enough, but also to smaller institutions here in the United States or in Canada or wherever, to independent researchers, to citizen scientists, right? These are whole groups of people that are excluded from being able to do these kinds of analyses. So that's not the only problem, though. The other problem is that even if you can't afford to pay to play, even if you can't afford to get this data, you can't share that data. You can't share the results of your analysis. And that's specifically a problem for three main reasons: for transparency, that's a hard word for me to say, reproducibility, and integrity. So those are our three big problems with not being able to share the data. So what I mean when I say can't share data, so I've done research like this. I download some big chunk from, let's say, Web of Science of data. I ask my question, my research question. I publish my paper about it. And then someone reads the paper and says, oh, this is an interesting paper. I'd like to extend your work. Where's your data? And at that point, I said, well, I don't know, I may or may not be allowed to share that data with you because it's proprietary data. My institution signed a contract. It's like a lot of lawyers went over about how much I'm allowed to share or not allowed to share. Sometimes I can by request, sometimes I can't, but it's very confusing, and people mostly just don't. And this is something that for like 20 years in the broader scientific ecosystem, there's been a tremendous amount of effort to solve. There's lots of people trying to share genomics data, trying to share climate data, right? It's become very well known over the last 20 years that this is a huge magnifying effect on scientific research. If not only do I write the paper, but I also give you the data, you can rerun my analyses, or you can tweak it and run slightly different analyses, right? It's a huge savings. It's a huge savings on labor and on effort. And as I say in this transparency bullet, the point of this transparency is not only does it save me effort, but it also helps me believe in what you're doing, right? Like if I make some sort of a point and I say, well, this is, this is the finding in my study, right? Like teams with more diverse gender balances are more likely to be highly cited. I tell you that's true. You say, oh, great, show me the data. I say, oh, I can't show you the data. Right? Oh, I don't know. That starts to maybe feel like, is this really science, or are you just making bald claims that you can't even support? So I think especially when these claims end up having, again, billion-dollar consequences on how we fund research and what kind of research we fund, it's really important that we're transparent. I already kind of mentioned, like I said, reproducibility. I went a little bit out of order. We can save a lot of time if we can reproduce each other's study. And then to me, a big part of it is just integrity, too. If we're telling people, particularly when we're using these analyses that some of us in the sort of science of science or meta-science community do, and we take these, we create this analysis, and then we say, well, you should be more open, but I'm not open with my data, so why should you be more open with your data? So I think that's kind of an integrity piece of it there as well. So that's kind of the sharing part of it, right? And then the last thing I say is you can't build on them. That's a big one for me. I like to build things. I built, was part of the team that built OpenAlex, and there's so many cool things you could build on the citation graph. So I keep coming back to this gender diversity one because I just heard that study a day ago. But I thought, how cool would it be if I could have a tool where I type in my name, and the tool looks at all the papers I've written, and it looks at the gender diversity of the teams that I've worked with, and it says, okay, well, here's your gender diversity index. Maybe it's a little low. Okay, that would be kind of helpful for me. But then what it could also do is it say, here's a bunch of people working more or less in your field who maybe you could collaborate with for your next paper, and that would increase your gender diversity, right? There's a tool that could be built that would do that automatically, right? But no one's doing that. Why not? Because you can't build that on something like Scopus or Web of Science on these very closed data sets. They're not allowing that to be done, right? No one's doing that. And there's a million tools that I could build, right? I want to make a tool that would automatically write a lit review for me, right? They would I would tell them, here's what I want to study, show me all of the papers that I should probably read. That's a conceptually possible tool, right? But no one's building that tool, right? I want a tool, there's already some tools that exist, right? Tools where I can go to a website and I can say, hey, let me type in my university, and you can tell me how open is my university, what's my open access sort of quotient, and where are some areas that I can improve. Some people have already built some of that stuff, but they haven't been able to build them on things like Scopus or Web of Science, again, because that's closed lockdown data. So these are our three big problems why paid-to-view SKGs are broken, is that we can't afford them, we can't share them, and we can't build on them. So OpenAlex is designed to solve this problem. It's an open scientific knowledge graph. And when I say open, I mean open along a number of different dimensions. So specifically, it's open source code. So that means all of the source code that we've written that generates the data behind OpenAlex, that's all available via an MIT license. So you can, does two great things. Number one, you can see everything that we've done. So if you're curious how we did something, you can just go look it up. All the code is right there, right, for anybody to see. That's one cool thing. And the other cool thing about the open source is that if you want to replicate parts of what we've done, you can do that. If you want to, build your own version of OpenAlex, you can do that. You can take our code and build your own thing. It's going to take you a little while, but you can do it. If you just want to build part of it, you can build part of it. So that's the really cool thing about open source, and that helps you, again, sort of trust where that data is coming from. There's transparency on our end. When we say, hey, we've given you this data, we've showed our work, right? When I was a kid in math, you had to show your work. I assume it's still this way. And if you just write the right number but you don't show your work, it's you don't really get a good grade because it's I don't know how you got there. Right? So it's the same thing I feel like for the scientific knowledge graphs. If you can't show me your work, I don't know how you got this data, I don't give you a good grade, right? So I think OpenAlex gets a good grade on this one. At least that's the way I see it. So the next part is open data, right? And As I mentioned, all of the data behind OpenAlex is completely free and open, and we'll dig into exactly what that means in a second. But one of the things I want to highlight is the license. So that's the legal terms by which you're allowed to reuse the data, and this is a CC0 license, or public domain, which means no rights reserved, right? Like we don't have any rights to the data. So we just put it out there, and you can use it for literally anything you want. You don't have to give us any kind of credit. You don't have to link back to us. You can use it for whatever you want. You can chop it up and use it on your own projects, no problem. And that's the maximally useful version, right? So a lot of folks in the open data community really recommend that CC0 license, and that's the way we like to do it as well. Usably open. So these second two are sort of ones I came up with. They're not like, you know, open source and open data are like real things. These two are like just my things. But I think they're important because I've used a lot of open data tools. And so I like to say usably open because something could be like officially open access, but it's really hard to get at. Like it's hard to actually get the data or like do anything with it. So when I say usably open, I'm talking about three main ways that you can get the data. And those are via an API. And so an API, right, like I'll show you what that is in a second, a web UI, which everyone's kind of familiar with. You just go to the website and click around, and then via a snapshot. So you can download the entire data set just with one big swoop. Oh right, and I should mention too that usably, which I didn't put on the slide, the other cool thing about usably, the other thing that makes the data usably open is that it's up to date. So the thing that you download isn't like a thing from a year ago, it's a thing from 2 weeks ago. So we update that snapshot every 2 weeks or more. And so that's I think, kind of a handy thing, too, depending on what kind of stuff you want to build on it. Finally, we are sustainably open. So that's something that a lot of people ask about. They say, well, how is this thing, you know, if you're giving away the data for free, how are you able to do that? How can we be sure it's going to be here next year, or the year after that, or the decade after that, right? And so that's a big topic, and we'll get to it in a minute, in a few minutes, actually, in greater depth. But the biggest key is that we're able to do it for really cheap. And so we'll come back to how we're able to do it for really cheap. But because we're able to do it really cheap, we don't need a huge amount of revenue to be sustaining. But the revenue that we do need, we think it's very important that revenue comes from earned income rather than from a grant. So we have a grant. We have 2 years still left on that grant from the Arcadia Fund, which is awesome. They've been very generous with that. But as that 2-year grant starts to expire, we'll definitely be transitioning to earned revenue. And for other products that we've done at our research, so our nonprofit, which is called Our Research, has been around for about 10 years now. So we've done this for a while. And the way we stay sustainable is by selling, instead of the data, we sell services. So in particular, a lot of times we'll sell super fast access to the data. So if you want the data pretty fast, it's free. If you want it crazy fast, that costs us more money, and we kind of pass that cost on to you, and that is able to subsidize the rest of it. So that's a method that's been working for us for, like I said, 10 years, and that's something that we'll probably be extending to OpenAlex as well. I say nonprofit because I think that's really important. I think that for-profits are quite they're quite attractive acquisition targets. So a lot of times someone will take over that for-profit, and then they'll change the business model. So we're nonprofit. It's like not so attractive to acquire us. So that's the thing that can kind of keep the data open. And then finally, POSI, I want to just give them a shout out. It stands for Principles for Open Science Infrastructure. A terrific initiative, not started by us, but it's definitely something we enthusiastic support, which is a list of, I want to say like 10, some number of principles, basically some of the ones I already described to you about keeping things open, about having a good revenue stream. And there's a number of organizations that have signed on to this, and we're proud to be kind of early signatories to this that have a whole set of principles to help make sure that we're here for the long haul. So I mentioned that the data is open. I just want to give you a couple quick examples of what that means. So this is the API. I think most people are probably here comfortable with what API is, but just in case not, it's just an automated way for computers to get the data. And so it's not the prettiest to look at, but it's real pretty for computers because they can understand it super easily. So you just go to api.openalex.org/works, and it will show you every work in our database. And so you can see there's about 236 million. And if you want to just page through that, you can get all 236 million works just going through pages. We encourage you not to do that because it'll take you forever. But you could do that, which I think is kind of nice. To me, I find it pretty. It's all just right there. More useful a lot of times is you want to filter it a little bit. So you can see this part that I've got highlighted. They show me how to do this a little quicker. Let me see if it works. It's really cool. Okay, I can just point this little dot at it, which is neat. Yeah, you can see this little filter that's highlighted. So this is a filter for the institutions that have the ROR, which is an ID for institutions. We'll talk about that in a minute. And this ROR ID, this unique ID for institutions, is for the NIH intramural program. And so you can see that there are about 320,000 works that we have found that were authored by someone affiliated with the NIH. And again, you could just paste through those and find all those works if you wanted to. But again, sometimes it's handy to like narrow it down a little bit more. And so what I've done is I've added this second, again, it's highlighted, and you can kind of see this second little highlighted area, this group by. And what that means is that it's going to group by what the access status is, the open access status. So you can see that this group on the top is closed. So that means like there's no open access copy. People are going to have to pay to read it. This one is bronze, green, gold, unknown, and hybrid. And so each of those have their own little definitions that you could look up. But the most well-known is like maybe gold OA. So if it's gold open access, it means it's in a journal that anybody can read for free. And that's something that a lot of policymakers are really interested in. So this is the type of thing that you can kind of monitor your policy adherence that way. So I mentioned that there was 3 ways, right? There was the API, snapshot, and a UI. So this is the snapshot. I think this is so cool because you could just go there right now. I highlighted the URL, so if you just want to go there, you can click around and you can download the entire open access data set right now, just to your laptop. It'll take a while, and you're definitely going to want a big network because it's massive, massive, massive. But it's just available for free, and that's something that I don't think anybody else or not very many people have ever done. There's no cost. This was sponsored by Amazon Web Services. We're very thankful for them for that because it actually costs about like $60 just for the bandwidth. The Amazon bandwidth to download it, and they cover that for us, which is awesome. So you can just go do this, like I said, anytime you want. The download is extremely easy to work with. It's just 5 files. I can take questions about that if you want later on. But the nice thing about this is everything is available to you, everything that we've got. And then finally, a web-based UI. So we've got kind of a provisional UI right now. This isn't live on the web yet. This is coming in like end of August, beginning of September. But it just gives you an idea of the type of things you'll be able to do. You can see over here on the left, I can facet, right? So I can look for things that have full text. I can look for things that, in this case, are published in Nigeria, right? I can filter by any number of different things. I can search, right? So I'm looking for works about frogs right now, and I got my list of frogs, and then I could zoom in on one. So I've clicked on this top one, and you can see that now I've got the journal, I've got the authors, the concepts, and the citations. And then I can click on any of those, right? And I can go there. So if I want to learn more about F.V. Udo, I can click on that. If I want to learn about, see other chemistry articles or traditional medicine articles, I can click on those. So there's a way to sort of navigate all this. It's pretty standard. The other cool things that are maybe not quite as standard is this download. So I can download 100,000 rows to CSV. So it's super easy for me to get, again, the data. And then I got this little alert, so I can set an alert on that search so that any new open access articles about frogs published from Nigeria, I can get an alert on my email, which I think would be pretty cool. And then, of course, yeah, I got the full text. I got a bunch of other stuff, too. So that's the other way you can get at the data. So that's why I talk about the open. I think that's the most important thing. That's why I like to get that up front. But if it was completely open, and yet the data wasn't that good or the data wasn't there, that wouldn't be very helpful, right? Like, so what we need is something that has the coverage and the quality of a Scopus or Web of Science, but is completely open. That obviously is a challenge. If that were easy to do, someone probably would have done it already, right? So then the question is, well, how are you guys able to do this? You're telling me the coverage is great, which it is. The quality is comparable to these commercial services, but instead of charging, hundreds of thousands of dollars or whatever, you're giving away for free. How are you able to do that? And the answer is because it's super cheap for us to make. Why is it super cheap to make? Why wasn't it super cheap to make these other things? Well, there's 4 reasons why it was super cheap for us to make. The first one is we leveraged open data from Microsoft Academic Graph. Microsoft Academic Graph, henceforth MAG, was a terrific project from Microsoft, as the name implies, where they went and they built their own open science graph. It was an open scientific knowledge graph. It was really cool. It turned out to not be financially sustainable for Microsoft. They didn't want to keep doing it, and they were always just taking a loss on it, so they eventually they discontinued it at the end of last year. But what's neat is before they discontinued it, they created a really, really valuable data set that had an enormous amount of really high quality data. It's been highly studied. There are dozens of studies in the scientometrics literature about MAG right now. There are tons of tools, thousands of tools built on MAG. So it's a really well studied and validated resource. When they went away, they just made all of that data available to anyone. So that data forms a lot of the backbone of OpenAlex. We're really excited and we're really thankful that we got the opportunity to leverage that. That being said, of course, new articles are coming out all the time, right? So we can't just sit on our laurels. Oh, we've got the MAG data set, now we're done. So in order to process this new stuff, we also still need a couple advantages, right? We need a couple ways in which this could be cheaper than existing approaches. So one of them is there's lots of great open source machine learning libraries out there now. So when I talk about machine learning, right, I'm doing things like, if there's a paper that comes out and it says author is Jason Priem, but there's another Jason Priem somewhere who's not me but has my same name, that's a really hard problem to try and figure out which one of those Jason Priems is it, right? Author name disambiguation, they call it. And that's something that maybe 10 years ago was almost, or 20 years ago for sure, was almost impossible to solve with a computerized system. Now it's very easy to solve, much easier to solve with a computerized system. So that's one of the cool things that we've got going for us, right, just over the last couple of years. Another big one is we've reached a tipping point where the majority of scientific literature is available for free via open access. So more than half of new papers that come out are open access. It means that we can get those papers and we can scan the papers automatically and we can pull out the authors, we can pull out the citations, we can pull out stuff like that. Before, that would have been very difficult because it was total access. And then finally, open PID graphs. So PID, P-I-D, stands for persistent identifier. And we're going to talk about those a little bit more, but in fact, I think I have my next slide, yeah. Specifically, these PID graphs were created to try and solve the problem of ambiguity in the scientific record. The idea was to say, hey, every single entity should have a unique identifier that exactly identifies that entity, in the same way that I think some people are used to you might have a social security number as a person, right? Like if you're an American, it's a unique identifier for you. And so similarly, there's been a huge amount of work, enormous amount of work into building these PID graphs, these permanent identifier graphs for different entities in scholarly records. So for works, we've got Crossref, DOIs, and as I mentioned, COSI for citations. For authors, we've got ORCID, which stands for Open Researcher Contributor ID. For journals, we have the ISSN. That's been around since the 70s, which is really cool. For institutions, we have a relatively new thing called ROR, Research Organization Registry, which is terrific. That's only been around for maybe 2 years or so. And then for concepts, we have Wikidata, which is, again, relatively new and certainly has grown a lot in recent years. And in all of those cases, we've got a unique ID. And along with that unique ID, we've got a lot of metadata. So we can pull in all that metadata. And that's very cheap for us because a lot of the work has been done up front. Kudos to these terrific organizations who've done this. So those are kind of the four things we can rely on that allow us to do this so much more cheaply. The way I always kind of think of it is, the first scientific knowledge graph, if you want to call it that, which was Web of Science, that comes from Eugene Garfield's terrific work in the 60s. And when he built that, that needed to be a manual process. Like you had to pay dozens or hundreds of people, sit down there and look at paper journals, type down, oh, here's a citation, right? And it was extremely, extremely expensive. Over time, we gradually were able to automate more and more and more of that. And so scientific knowledge graphs has gotten more and more and more comprehensive and more and more and more cheap since then. And I think that OpenAlex, rather than just being, hey, we're such geniuses, we do our best. But I think it's not so much that we're such geniuses, it's more just the technology has gotten to the point where we can do this so cheaply that it makes economic sense for us to give it away for free. So, right, and the other example I have of how these PID graphs have made things a lot easier are the DOI graph. So that's the PID for works, right? So every scientific article, or most scientific articles, has got a DOI. And specifically, I can say these two graphs, the first one shows the number of works, or in most cases the works are articles, so I'm just going to say articles, the number of articles in MAG and the ones in Crossref. So the Crossref means has a DOI. So you can see that the red group at the top, over the years, there's less and less and less in the scientific literature that doesn't have a DOI but is in MAG. So MAG is sort of everything, but over time, that everything, more and more and more of it has got a DOI. And so the bottom graph is really just a graph of the red part of the top graph. So it's just a kind of a zoom in of that red part. And you can see that the number of works that don't have a DOI, right, that are in MAG but they haven't been assigned a DOI, that number of works just goes down, 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 down all the time. And so if you wanted to extrapolate that curve, you might say that in 5 or 10 years, there will be almost no works at all that don't have a DOI. And what's great for us is that DOIs are extremely easy to access. It's super easy for us to get the metadata for DOIs. So this makes our job way, way easier. And what's encouraging is our job is only going to get easier over time. More and more and more of the literature will be assigned to DOI and therefore can easily be retrieved by our systems. So what's cool about this is not only is OpenAlex more open, but it actually has better coverage than a lot of the commercial services because of this approach that we're taking. So I have a little table here, and I'm not going to like bore you by going through every cell of the table, but I just want to kind of point out Web of Science and Scopus. These are at the top just because I think that they're, they're like I said, they're kind of dominant one. Google Scholar is in here, and I think it's sort of a question mark about whether it even counts as a scientific knowledge graph because it does have a UI, so you can go there and ask it questions, but you can't actually get the data out for any amount of money. So, like I said, depending on how you define them, that's either an OSG or not, an SKG or not. And then you've got MAG. Like I said, that's kind of where we started from. Dimensions, as I mentioned, Crossref, and OpenAlex. So I think you can kind of, again, like by looking at this, you can see that our coverage is much, much higher than Web of Science and Scopus, right? So they're looking at in the 80 millions. We're talking about 236 million, so massively higher. Citations about the same. Authors way, way, way higher. Venues way, way higher. Institutions significantly higher. Scopus is doing a little bit better on that one. But then what's, like I said, kind of cool is our coverage is also better than MAG. It's not massively better, but is notably better in a couple of these areas. And the reason for that is because MAG didn't really believe in the PID graph. They didn't like PID graphs. They just, we're going to keep that out of MAG. We feel exactly the opposite. We think the PID graphs are the future. So that's why we're bringing that PID information into OpenAlex. And that's why we're able to have a little bit better coverage even than MAG, which was sort of one of the best things going before us. One of the neat side effects of having this great coverage is, and I don't even say side effects, like one of the great effects of having this coverage is that we're able to cover areas that have been traditionally neglected by other scientific knowledge graphs. So specifically the global south, right, which is sort of a lot of the less developed countries in the world. So we've got 22,000 institutions located in countries in the global south, 21 million authors, and 22 million works, all coming from those global south countries. Now that's not a huge percentage of the graph, but it is a large number in absolute terms, and it's certainly a lot more than what you're going to get from these legacy, kind of old-fashioned commercial scientific knowledge graphs. Also, about a third of our works are in a language other than English. So you may recall that's less than 10% for Scopus or Web of Science, but it's more like a third for us. Again, that coverage, it helps a lot of different things, and one of the things that helps is representation. And I mentioned here the sources, our API, which I think is really cool. So you can see over here, if you click on that link, you can get it. But you can see this is, this is a couple dozen lines of Python that we can use to get these numbers. So you can run these and get your exact same numbers. And a good example of how open data and open API means instead of me just telling you these numbers, I can give you a link, you can run it yourself. And if you want to tweak that a little bit, you can, right? You might wonder, okay, they say their coverage is pretty good in the global south, but what about recently, right? Like how about in the last 10 years? That's just one parameter on that API call, right? So you can tinker with this and you can modify those questions any way you want. And I like that a lot. So I want to talk a little bit about, it's maybe a bit of a digression, right? What I've tried to argue so far is that scientific knowledge graphs are very important, but they're broken because they're closed. We're better than that because we're open, so we're trying to solve that problem. We also have great coverage, so that's really good. But I want to do a little bit of digression to say exactly what is in OpenAlex, right? What can you find? So we're just going to dig into that just for a couple minutes and then wrap it up. So there's 5 main entity types in OpenAlex: works, authors, venues, institutions, and concepts. And let's just dig into exactly what I mean by that. So works are papers, data sets, software, and so forth. So anything that someone made, right, as part of the scientific research process could be a work. So that could also be, there's the examples I've got here, but that could also be a poster. It could also be a piece of software. Well, I mentioned the software already. It could be a talk, right? It could be a conference paper. There's a whole bunch of different things that might count as works. And those are all in there. We want to make all of those siblings, right? They all are just as valuable in their own way as another thing. Authors are people who create works. So pretty straightforward, right? Just whoever's making the work, that's an author of the work. Venues is a little bit of a tricky term. The reason why I say venues instead of journals is because a lot of a lot of works, and a growing percentage of works, are hosted by something that you wouldn't call a journal. So it might be something like Archive, or Zenodo, a preprint repository, or an institution repository. These aren't really journals, but they are a place that publishes with a small p. They make the work available publicly, and we don't want to discriminate against those. In fact, we think those are the future. We really like those, so that's why we call them venues instead of journals, because it includes both journals and repositories. The vast majority of them are journals for now. And then institutions. Institutions are about affiliations, right? So they're, of course, they're organizations, like a university most of the time, or a research center or something like that. And they're affiliations that the authors claim. And then finally, concepts is what the work is about, right? So the work could be about frogs, or it could be about biomedicine, or whatever. So those are our 5 main entity types, and then we connect all these entity types. So, oops, I lost it. I have a graph somewhere. Hang on, don't peek. There's my graph. All of these different entities connect, and this is a very rough, just kind of way of envisioning what that looks like. Works is sort of at the center. Everything's about the works. And then a venue, right, links to work because the work was published in a venue. So that pink line would be published in, right? The orange line would be is about, right? So the work is about a particular concept. This gray thing, authorship, is sort of an imaginary idea. It's not an entity of itself, but it links authors and institutions with works. The reason why we kind of need that is because as an author, I might claim my University of Florida affiliation for this work, but I might claim my NIH affiliation for this other work. And I'm a part of both institutions, but maybe I just don't want this one to be affiliated, or I don't want this one, the other one, right? So we kind of have to think about an affiliation as really a 3-way link between a work, an author, and an institution at any given time. So that's kind of our little graph. Let me go back up. And I kind of mentioned already the numbers. So there's 236 million works in OpenAlex. We support a number of different IDs. The main IDs we have are DOI and PMID. We get those works from a whole bunch of different sources, but Crossref from the DOIs is one of the big ones. We get some of them direct from journals, and we get a lot of them from repositories. So we harvest these repositories. So those are kind of our main sources of works. We put a lot of effort into disambiguating works. So a lot of times there might be one work that's in a journal, and the same work is hosted in a preprint repository or a disciplinary repository somewhere. We got to do a lot of work to figure out these are the same and put them together. So that's something that's a really big challenge, and we think we're doing a pretty good job of it. And then also the links between works, which isn't in that graph but are really important, are citations, right? So one work cites another work. So we put a lot of effort in making sure we've got citations, and again, our citation count is very comparable to what you get from the commercial services. Next, we've got authors. About as many authors as works. The key identifier for authors is the ORCID, which I mentioned earlier. The majority of our authors don't have ORCIDs. However, we definitely link our author clusters to ORCIDs wherever possible. And we even do something kind of cool where if, like I, Jason Priem, have got, like about 40 works, and about maybe 3 of them have got ORCIDs assigned to them, right? Because it just didn't come through, like the publisher didn't ask for them or whatever. But in OpenAlex, when OpenAlex sees that 3 of my works have got the same ORCID, it says, oh, I bet all of this guy's work should have that ORCID too. And it will go through and assign ORCID to all of my works, which is pretty neat because it means you can search by ORCID, and if the authors ever used their ORCID, then you'll be able to find it for all of their works, which is quite handy. Again, like with works, disambiguating is a huge problem. I've kind of referred to that a few times. And so we put a lot of effort into trying to differentiate this John Smith from this John Smith based on their co-author history, especially based on their citation history, because they tend to cite the same things. If you're the same person, you tend to cite the same things from paper to paper. The venues I mentioned already, and I mentioned why we call them venues. We've got about 100, oops, I got the wrong number for that, sorry. Okay, so this says ROAR, but it should say ISSN, my apologies. This slide was done in a bit of a rush. So we've got about 108,000 venues, and we use the ISSN International Standard Serial Number to disambiguate those. We've got a really cool thing in this database where we actually, so a lot of, if you do a lot of research in this, you find that a lot of venues got multiple ISSNs, which is extremely annoying. So it can have an ISSN for the paper version of the journal and another ISSN for the electronic version of the journal, even though the same journal. Super irritating. And there's a thing called the ISSN-L, or linking ISSN, which is designed to rectify that confusion. So we've gone out and found the ISSN-L for all of these venues, which is extremely convenient for research purposes because you get like a numerical, unambiguous identifier for each venue. The institutions should be ROR, so that's where I got them backwards, I'm sorry. ROR, like I said, Research Organization Registry, they're doing a terrific job. They extend an earlier project called GRID. It's a completely open registry. They've got a lot of institutions. One of the neat things that we've been able to use ROR for is, again, as an author, and you can kind of get a theme here, I could say my institution in a whole bunch of different ways. And there's a lot of ambiguity around that, right? So I might say University of Florida, I might say UF, right? I might say Massachusetts Institute of Technology, I might say Mass Tech. Like, who knows? Like, people have all different crazy ways of referring to their institution. And this is a big challenge, and this was an area where we were able to rely on machine learning. We trained an algorithm to recognize all the different ways that a person might refer to an institution, taking into account, the geography. If they say if they say Miami University, Ohio, right? We know to look. It's a different university. So we put a lot of work into that. And one of the cool things we were able to use ROR for is ROR has got a canonical list of all of the different names of a particular university. And we use that list to help train the algorithm. And the algorithm performs really well. We're really excited about that. And then finally, concepts. So every single paper is tagged with a concept. I think there's a few that haven't been tagged, but the majority of the papers have been tagged with a concept. Generally, they're tagged with more than one concept because it's sort of a hierarchy, right? So you might start with history, and then from history, you might say social history. And from social history, you might say, well, social history of the British Isles, right? So you can kind of narrow it down. And our algorithm will assign generally like 3 to 5 concepts at different levels of that hierarchical tree to every individual article. The neat thing about an article level taxonomy rather than a journal level taxonomy is that when you're trying to normalize citations, you don't have to worry about journals like, let's say, PLOS, Public Library Science, PLOS One, that have got every type of field in them all together. So when you're normalizing is a huge issue, right? Like a citation in biomed is much easier to come by than a citation in philosophy. So it's not really fair to count the citations that a philosophy paper got compared to a biomed paper. You need to compare them like relative to other psychology papers or philosophy papers, right? So this tagging system makes it really easy to do that. You've got that data right in front of you all the time. We're really excited about that. And again, that's like a machine learning thing. We used a gold standard built from MAG's classification, which was pretty good, and extended that gold standard, used that gold standard to extend that work to new articles. I already showed you this. There are some limitations, like everything. Just a couple quick notes on that. So we definitely inherit our bias from sources. So Crossref and MAG had certain biases. Crossref has a well-known bias towards STEM fields and towards the global north, more developed countries. The nice thing is that Crossref has put a lot of effort into getting more adoption from humanities and social science as well as the global south. So that bias isn't as bad as it used to be, but it's still there. MAG, the nice thing is, kind of cancels out that a little bit, but those biases still exist, and I think it's good to be in front of those. There's not a lot of research on OpenAlex specifically, which is not ideal. That's something that we're hoping to spur with talks like this. We want people to get that research going. The cool thing about it is the majority of data points do come from MAG, and MAG is heavily studied. So that's an area where we think, even though we'd love to see more research, we feel like there's at least a little bit of a research base. We do have some holes in the coverage. So as I mentioned, I think our coverage is really good in those 5 entities, but there's definitely some areas that we're trying to extend. So we don't have funder information, which would be amazing. That's something we'll definitely be looking into, but it's not there right now. So we can't tell you who funded a particular study or filtered by funder. Also, we don't have patents. So MAG had patents. We actually made the choice to get rid of the patents. We feel like there's already a number of good patent databases out there, and therefore we don't think, that patents are different enough from the other types of scholarly works that it was confusing. We may add them back in if there's a lot of demand, but for now, we're going to keep patents out of the database. And then our coverage of software, data sets, and books is okay. It exists, but it's definitely something that we would like to improve a lot. We're very big proponents of these kind of alternative scholarly products, and we'd like to have terrific coverage of them. And then finally, stability. So the data is very stable in terms of if you look for it, it'll always be there. But it is changing regularly. So we just added 30 million DOIs to the system this week. So what that means is if you were trying to look at the number of citations that something had 2 weeks ago, and now you look at it again this week, all of a sudden it's got 20 more citations. Where did these all come from? Well, it's because we added a bunch of new DOIs. We've got more data, which is good. That's a good thing. That's what you want. You want the thing to be growing. But when it comes time to compare measurements across different repeated measurement events is something that you'll want to keep aware of. One cool thing about it is you can always kind of go back in time with the snapshots. So you can kind of stay a little bit constant, but as the algorithms change, it's still going to change a little bit. So those are, that's kind of limitations. That's mostly it. The main takeaway, like I said, is that I think that this thing is open. Anybody can use it, and it's ready. I think it's got great coverage, and we really want people to go play with it. We want people to poke at it. We want people to find what's great about it, find what's terrible about it, build stuff on it. Let us know. Be in touch. We think of this as a community-oriented thing. Part of the whole idea of citation indices that's always appealed to me is that it's taking a community, right, like those of us in the sort of scientific community, and saying, we built this resource ourselves, right? Like all of these links in that citation network are citations that I added to one of my papers, that you added to one of your papers, right? That individual people said, hey, I think I should cite this here, right? This was a judgment that someone made. And all those 1.8 billion citations are all some expert judgment that some expert person made as part of writing their paper. And I think that's really beautiful. I love that we built that ourselves as a scientific community, and not just a scientific community, but as humans, right? Like the scientific literature represents, I think in many ways, like our best effort as a species to try and understand what this is all about, right? Trying to make our lot a little bit better in life. And I think it's very beautiful then that is very open. I think that needs to be open. It's something that all of humanity has added to over the years, over the centuries, over the millennia. Why is it that only tiny segments of well-funded humanity should be able to see it? I think that's quite ugly. I think, on the other hand, something like OpenAlex, where we can make that available to everybody, where it's our thing, right? That's why our nonprofit's name is OurResearch. This is our thing together, our research we've all done together, so it should belong to all of us. It should be available to all of us, and I think it should be a project that we all do together. So that's why I'm asking everybody who uses it, let us know what you like, let us know what you don't like, we'll build it together, we'll make it better together. So that's pretty much it. We've got kind of a small audience here in person, but I wanted to open up to any questions that folks have. Thank you.
Thanks, Jason. I just wanted to say also we've got a lot of people watching online. If you're at videocast.nih.gov, there's a link there for live feedback. That email should go to me, but we're just dealing with some technical stuff. Also, if you want to tweet to @OpenAlex_org, we'll watch those tweets and we can repeat those questions here. We've got a few more minutes. Anything from the audience? Go ahead, Al.
Thanks, Adam.
Can I use the mic?
Yeah, so it'll go out to the video cast, sure.
All right, so I've got a bunch, but I'll start with a couple and then give other folks a chance.
Great.
So you talk about sustainability. Are there sustainability concerns in terms of being able to keep it open in the way that it is now, with relying on kind of like the largesse of Amazon to give you guys free bandwidth for exfiltrating data?
Yeah, good question. So we've got 2 years of sponsorship from Amazon, so that gives us a little bit of time to think about it for sure. Mm-hmm. And as you say, $60 a pop is expensive. So I think one possibility could be, after that Amazon sponsorship expires, if it does, because there's a possibility to renew it. But if that does expire, then that would be something potentially we would need to pass on to users. So we might need to say, well, the data is free, but you're still going to need to pay the $60 transfer cost, potentially. Or potentially, if there's not enough people downloading it, maybe we could cover that internally. 2 years is a long time, so it'll just kind of depend on how well we're doing financially at that point.
If I remember AWS's cost structure right, I think it's usually free to transfer within AWS, right?
Yeah.
So you could potentially set up an API so that people could like extract a snapshot to their own bucket and then
Yep.
play with it on that side, and then
For
they
sure.
have to pay the exfiltration costs.
Yep, absolutely. We'd be
Yeah.
more than happy to do that, yeah.
No, that'd be one way to do it. This is kind of just a nitpicky question. Why does MAG have 1,000 times the authors that OpenAlex does? Or was that not supposed to be a B?
I think that was not supposed to be a B. Thank
Okay.
you very much.
Yeah.
Much
Yeah.
appreciated.
Yeah, all right.
Which one? This one's actually from me. So the coverage is really impressive. I remember you mentioned that you're reaching out to a lot of places that are not traditionally covered. Where do you draw the line? How do you decide what not to put in there?
Yeah, great question. Thank you. And it's definitely a philosophical question that's always interested me, because I think in the olden days, when knowledge was something that needed to be moved with paper, which is inherently scarce, people tended to think about exclusion. That's the way people wanted to think about it. It's either in or it's out. And that's how something like the journal impact factor, right, is calculated, right? Like they say, there's some journals that have one and some journals that don't, and you're either in or you're out. I think in the electronic world, I think things don't want to be that way. Things don't want to be in or out. You want everything to be in, and then you rank the things that are in. Because there's no reason to throw it away. Paper's not expensive, right? Like paper's expensive, bits aren't expensive. So to me, I think the goal is actually we want to include everything that's not, actively, whatever, offensive or deadly or something, but within any reasonable level, we want to include everything. And then we want to allow people from the community to create reasonable rankings or quality judgments on those things. And then you could filter that. So one effort that I think is really cool is JIPS, JPPS. And this is something that a number of I think it came from African Journals Online originally. And their idea was, hey, we're excluded from the whole journal impact factor world. Like, we're not allowed to get one of those because we're not high enough quality. But we still want to rank our quality. So they created this JIPS thing, JPPS, and there's a 1, 2, 3, I think, 0, 1, 2, or 3 star rating that you can get for your journal based on your editorial policies, based on your peer review policies, based on the quality of your submission guide, stuff like that. And so you can get a quality judgment for your journal, and it's not an in or out. It's just how good is it or how good isn't it. And that's the kind of thing we will be bringing JIPS into OpenAlex, and we want other initiatives like that where we can say, if you want to see only the top 100 journals by whatever ranking you want, great. Then you can filter your search to those top 100 journals. If you want to see everything, then you can see everything. So that's kind of our philosophy for journals and for everything else.
Okay, great. Go ahead, Dustin.
Yeah, thanks. That was a great talk.
Thank you.
My question was, I was going to ask basically the same question that Adam asked, but I guess more practically, how often is the database being rebuilt, and are you making manual decisions about journals to include, or do you have an automated way, like say a new ISSN number is added? Because I guess I'm thinking more of obscure places to get works. And are you doing that automatically, and if so, how? Or are you making a whole bunch of manual decisions?
Good question. So MAG was built on crawls from the Bing search engine, so it was the entire internet. So that was their source. And then they, like everybody, had to kind of make a decision about what counts as, this is a scholarly index. So do we have copies of the New York Times? No, that's not scholarly, for sure. Bird watching monthly? Probably not. Birds, that sounds a bit like science. So you end up making all of these, and I think there's no real way to make those other than manually about, is this in scope or not? Our initial scope is much smaller. We're not scraping the entire internet. We're scraping a few sources that we think are more or less scholarly. But like MAG, like anybody, we have sort of a penumbra of, does this count as scholarly or not? And I think there's no way to get around that being inherently a manual decision. So yeah, I think you can either you can err broad or you can err narrow. But at some point, I think you're gonna have to make a decision about whether or not my dog's Twitter account counts as a scholarly resource. Would be my suggestion. Maybe I'm wrong.
So that seems like it seems like there's a lot of possibility for potential bias there then. I assume that your team isn't massive, or the people who are including aren't massive, and I assume that you're probably from a certain demographic area, a certain geography, and if you're wanting to include places that you might not know as much about, do you have a plan, or have you talked about how to avoid potential bias in that structure?
I think right now, like I said, the plan is let's aim way, way, way to the, I guess, left on the curve. In other words, include if there's any kind of doubt, include it. So that's kind of what we do right now. But I guess in theory, there could be something where there is massive doubt, and yet we're so clueless that we don't realize it. I think so that would be something for the future for sure. I think right now, given that our coverage is significantly broader than anybody else, it's not the area we're probably focusing on the most.
Yeah, when you brought up journal newspapers or something like that, it made me think of, Science and Nature, they have news articles, but they're given a DOI or something like that. So those are probably included in some way.
Yes, absolutely.
Whereas New York Times or something wouldn't be.
Yeah, that's true. Agreed. And we are very heavily dependent on, as I mentioned, the bias is inherent in something like Crossref. So Crossref is the same thing, right? DOIs are for scholarly things, and they kind of make a bunch of judgment calls about what counts as a scholarly thing, and we do inherit a lot of those judgment calls.
Okay, we'll take one from online. On the slide with the table indicating rough estimates of coverage, there were many question marks in the Google Scholar row. Why is that? Or is that information not available?
Yeah, great question. Yes, that is exactly why. That information is not available. The reason I even put SKG and Google Scholar is because I think it's debatable whether you would even call Scholar. Scholar certainly has its own knowledge graph under the hood, but since no one has ever seen it or been permitted to access it, it becomes like a tree falling in the forest like type of question. Like, no one knows the answers. And the ones that we do know are based on some pretty clever estimates by folks like Alberto Martin. And I'm going to add, this is online, and I will tweet out a link to the slides, and I will add a list of sources that didn't make it into this deck, so that people can, first of all, I want to credit the people who did some of the work to find these numbers, and also you can kind of dig into some of the numbers yourself if you're interested.
Okay, great. One more. You mentioned Wikidata. What about alternative ontologies? Is that the only one you're including, or are there other ontologies that are being mapped?
There's a couple that we map explicitly, so Mesh we map explicitly, UMLS we map explicitly. I think those are the main ones. But the reason why we love Wikidata so much is because Wikidata is probably the world's best universal crosswalk between a whole bunch of different ontologies. And so that's why MAG had some concepts that didn't have Wikidata IDs, and we ended up pruning those or finding Wikidata IDs for them, because we feel like this is, like, the Wikimedia community is amazing and about 1,000 times bigger than us. And so that's why we kind of want to outsource that to them. They put enormous amounts of work into building those cross tables between different ontologies and control vocabularies. And so we figured, hey, let's let them do what they're good at.
It's 1 minute till. We've got one last question. Do you handle preprints at various stages of editing or withdrawals? Would acknowledgments for comments or reagents be provided in some future states?
Great. So those are two questions. We do handle preprints. We have a ton of preprint. I think we probably have as good a coverage of preprints as anybody does.
The editing and the withdrawal stages, I guess.
I gotcha, yeah. Yeah, I think I'm a little unclear about the withdrawal stage. We do handle retractions, if that's what that's discussing. So we have what I think is kind of cool. We have a little key in the API about and in the data about whether something's been retracted or not. So you actually can find retracted stuff, but you can also exclude it. So again, it's kind of either way, your choice, because you might want to study retracted things. So those are available, but by default, like in the UI, they won't be shown. So that's how we handle retracting. In terms of editing, like, we do automatically determine the version of something. So whether it's pre-peer review or post-peer review. So that might answer that question. And then what was the second one?
Would acknowledgments for comments or reagents be provided in some future state? I guess he's asking if that's a feature you're thinking of adding.
Absolutely. Yeah, no, that's something we would definitely like to add in due time. Yeah, for sure. Acknowledgments, I think, are amazing. So, like, I think that would be a terrific source. Blaise Cronin did amazing work on those, and I would love to include, as a person, like, how often has it been acknowledged? I don't know. I have no idea. Maybe none. But it would be, maybe I don't want to include this. I'll just be heartbroken to answer. But it would be cool if it turned out someone had acknowledged me.
Okay, great. It's 4 o'clock. So thank you, everybody online. Thank you for everybody turning up, and thank you, Jason.
Thank you very much to the same people.